Hi, this is Sean. Welcome to Module 5, coming to you after you've had a chance to review some very mathy chapters on network analysis from Mark Newman. One of the things that we struggle with in learning analytics is that many of the techniques that we need to use to automatically assess learning and get an indication of how much learning is taking place or what different student behaviors are that go along with or correspond with learning and which ones don't, is that we're mixing very mathematical concepts that have a long history together with what we understand about how learning occurs, and in particular how learning occurs through technology. And those kinds of questions, the questions about how we get folks who are thinking actively about learning and the messiness of learning to work together with computer scientists and come up with ways that allow us to analyze learning in a more automated way at the same time while respecting the privacy and security of students. This is one of the reasons, or the main reason, that I'm working with people here in Berlin right now to try to put together a framework for understanding how we put a factory of data generated by students in a learning environment together through computation, but also through insights that come from what we know about learning, into a result that helps teachers to effectively manage online classrooms in particular. And you can see in a couple of ways. First, through the questions that you asked in the discussion board, how complex and confusing the different mathematical concepts can be. There's mathematical network and analytic terms for things like degree centrality, betweenness centrality, and brokerage or clique type behavior. And when you read through the math and you hear the explanations in an abstract sense, it can be a little bit confusing trying to figure out, well, how do I apply that in a learning context? How can these implicit indicators of student behavior and learning be used to help students learn more and help instructors identify groups of students who need more and less assistance? So the latter part of this module is focused on three aspects of that overall problem. First, I'm going to ask you to take a look at a couple of papers that I've had you read before in different ways. Scan them, not read them in detail from cover to cover, but pull out the network analytic concepts that are presented in these two papers and think about those concepts in those two papers in light of what you now know about network science and network analytics in general, and then respond to a couple of your classmates' posts from the last or first part of this module. Then I've also made available a GitHub repository with a very simple download link that lets you download the zipped file and open it up in RStudio. And I'll provide you a brief tutorial video about that as we get closer to that part of Module 5 as well. And this will give you a concrete sense of how network analysis actually takes place technically. It doesn't resolve all of the issues that you might anticipate or that need to be addressed. That's why we're still exploring learning analytics in an automated way. But you're going to get a real sense of how scientists and how early practitioners of learning analytic strategies are going to work together. And then finally, in the fifth part of the module, Module 5, right before your spring break, I'm going to ask you to take a look at and think about all of the things that you've learned so far, especially with regards to network analytics and network science, and blue sky an idea for how you might implement a learning analytics system that includes not only network analytic data, but other kinds of data. And I encourage you to think broadly and with vision about that part of the assignment. Thanks for your participation so far in Module 5. I look forward to keeping up and participating with you in the discussion forums, and I'll see you online.